Okay, we're looking at exponent laws and going through, basically we're reviewing here the laws that you've learned in junior high, extending it a little bit more to variables. In junior high, you used the laws more with numbers, but it's the same laws. So the first one is product of powers. So here we have a cubed times a squared. So if we show this the long way, remember powers are repeated multiplication. So you can see how we can come up with the law for this. So this is going back to the basics. So there's 3a's multiplied together and 2a's multiplied together here. Altogether, there's 5a's multiplied together, which is a to the fifth. So when multiplying powers of the same base, add the exponents, but the base remains the same. So it's really important, to remember that the base remains the same. I'm just going to fix this. Okay, so add the exponents and the base remains the same. Okay, so here if we have one exponent being m and the other n, then that's how we get our result. We add them together. So this is like your rule in mathematical form. This is in words. So then use this rule for this question. So that would be m to the 9. Right? 4 plus 5 is 9. I tend to try to think about in my head, what would this look like the long way? I never show it the long way, but I think, oh, okay, there's 4 m's and then another 5 m's, so in total there's 9 of them. Dividing, so we've got t to the 7 divided by t cubed, can be with a division symbol or in fraction form. The long way, you'll notice that that t divides out, that t divides out, that one divides out, and so you're left with 4 of them. Okay, so these are just ones in the denominator. So there's 4, which is t to the 4, and so from 7 and 3 we subtract. So we subtract the exponents, but the base remains the same. So here the base remains the same and we subtract the exponents. So here the base remains the same and we subtract the exponents. 12 minus 8 is 4. Power of a power. So now that we've reviewed product of powers, we can show this power of 3 as a repeated multiplication of what's inside the brackets, m to the 4th. And then that's a multiplication question where we now have reviewed that we add the exponents together. So that would be m to the 12. That's the same as 4 times 3. And so that's our rule. When you're raising a power to a power, you multiply the exponents, but the base remains the same. Okay, so this would be a to the mn multiplied together. So this would be a to the 15. Okay. Then power of a product. So we might have more than one factor inside the brackets. And so here notice that x there is a multiplication as opposed to this written x, which is the variable. So often we would show that. Now that we're in high school, we just show it as xy. We don't need the multiplication symbol. In any case, 3 factors, so 3 sets of brackets of x times y. And so really there's 3 x's and 3 y's, so x cubed times y cubed. It's all multiplication. So when raising a product to an exponent, raise each factor in the product to the exponent and then multiply the powers. So here, this is a times b, or sometimes we show that as ab to the m. So that's how I'm going to simplify. That's going to be a to the m, b to the m. I'm not going to show a multiplication symbol like that. Or you could put a dot in between. So that goes to each factor. It's different if you're adding in between, and we'll talk about that a little later. Or, well, you've already done that in polynomials, but comparing those types of questions. So here, important thing, don't forget about the coefficient in front. It's in the brackets. So that is 2 to the 4th, p to the 8, q to the 4th, and then evaluate the 2 to the 4th. That's 16, p to the 8, q to the 4. A lot of times students forget about the 2. So if there's brackets and the 2's inside, it needs to get raised to the exponent 4 as well. Power of a quotient. So same kind of thing. P over q here, that's a quotient cubed. Show it 3 times. And so really that's p cubed. There's 3 p's multiplied together in the numerator, 3 q's in the denominator, so p cubed over q cubed. So in raising a quotient to an exponent, raise the numerator to the exponent and raise the denominator to the exponent, and then divide the powers. So here, that's the same as a to the m over b to the m. If you could have simplified a over b, I would do that first. Think of order of operations before raising it to the exponent m. And we know here that b can't be 0. So here, that's going to be x to the 15 over 4 to the 5, and then evaluate that. So x to the 15, 4 to the 5 is 1024. Okay, 0 exponent. We can figure this out a couple of different ways, but by patterns, you can see that we know 2 cubed is 8, 2 squared is 4, 2 to the 1 is 2, so each time we're dividing by 2. And that's reducing our exponent by 1. So 1 minus 1 is 0, 2 divided by 2 is 1. So if the exponent of a power is 0, then the value of the power is 1. Okay, as long as the base of the power is not 0. So 0 to 0 does not exist. It's indeterminate. So as long as the base is not 0, it's always equal to 1. Now, if you have a number in front, or like if you had 3 times 2 to the 0, then it would be 3 times 1, which is 3, right? So just be aware there could be numbers in front of it. So a to the 0, so anything raised to the exponent 0 is 1, as long as that's not, a is not 0. So this big number to the 0 is 1. Another way of thinking about 0 exponents, if we had something like 3 squared over 3 squared, well, we know that that is 9 over 9, which is 1. We know from our quotient rule that we keep the base the same and subtract the exponents. So 3 to the exponent 0 equals 1. So that's another way of showing. So patterns or the power laws. Negative exponent, this is something that might be new to you this year, and we'll go through this a few times. But again, let's use our patterns that we have here. So same here, 2 squared is 4, 2 to the 1 is 2. So we keep dividing by 2. And our exponent keeps decreasing by 1. So that's negative 1. And so if we divide 1 by 2, we get a half. Divide that by 2, we get 1/4. That by 2, we get 1/8 as the exponent decreases by 1. So a base raised to a negative exponent is equal to the reciprocal of the base raised to the positive exponent, as long as the base of the power is not 0. Okay, so see how this 2 to the negative 3 really becomes 1 over 2 to the positive 3. 2 to the negative 2 is 1 over 2 to the positive 2. So a to the negative n is 1 over a to the positive n. Here, if there's there's just one factor that has a negative, we only deal with that. This 3 is a 3. It stays as a 3. It does not go down to the denominator. Y squared, that's a positive exponent, it stays as y squared. But x to the negative 4, to make that a positive exponent, it has to flip, take the reciprocal. So flipping is a non-math word, reciprocal is a math word. So the x has to go to the denominator to make it a positive exponent, in this case positive 4. Okay, and that's it.